Hola everyone, I'm Trisha Torrecampo, a freshman taking a Bachelor of Science and Economics at Engine Colleges. And I'm here together with.
Then Ashley Go. I'm a sophomore in BMMA or Multimedia Arts.
Okay, and today we will be talking about Malus ex domestica.
You're right, Trisha. We will tackle its basics, history, and how it addresses food insecurity.
Okay, so without further ado, let us get started. Okay, so the basics. Malus ex domestica, commonly known as the fruit apple or domesticated apple. Okay, so the explanation for this name is that the X in the name means it is a hybrid in botany. There are lots of apple cultivars, meaning apple breed them intentionally to get specific traits, though they still fall under the same species name.
It's bizarre how the humble apple is the same as the Malus ex domestica, right?
I know.
Now let's continue with its history. So the history of the apple is interesting because the apples that we have today didn't exist until a few thousand years ago. Malus ex domestica's original ancestor was a species called Malus sieversii, which is a type of wild apple.
Yeah, and it says that it grew from Central Asia's Chanshan mountain region. Most scientists say that Malus sieversii came from where Kazakhstan is located now.
And another fun fact, it was actually thanks to the Silk Road that apples could spread and evolve like they did. Traders across Europe and Asia would eat the Malus sieversii apples, and then they would throw the cores on the ground and leave it everywhere, so that the seeds could take root and interact with other species of apple in the area.
Oh, some of the apples also traveled out east and eventually became what are called soft apples in China. Compared to the usual ones, they were less than 2 inches big but really sweet, which is how I
That's cute. Meanwhile, the apples that traveled west crossbred with the European crab apples, also known as the Malus sylvestris. There isn't an exact date for when this started happening, but it's estimated to be around 4,000 years ago to 10,000 years ago. So these westbound apples were the ones that eventually became Malus ex domestica.
But take note of this. The genetics of the domesticated apple isn't that straightforward either. About 46% of its genomes come from the Malus sieversii, while 21% are from the Malus silvestris. Yet, researchers are unsure where the other 33% of genomes come from.
Maybe they came from other crossbreeding species in the area?
Probably, but still, we don't know which ones.
Hey Trisha, I was wondering, how does Malus ex domestica address food insecurity?
Great question, Ashley. Apples have become a crucial part of our lives now, whether it's in food, drinks, even in culture. You have so many ways to eat it as a fruit, in desserts, as cider, vinegar, salads, even as sauce or butter.
I've never even heard of apple butter before.
Oh, me neither. But the point is, apples can be bred in lots of ways to suit the needs of the consumer.
Yeah, you're right. Nowadays, so many cultivars of apple exist that you can find the type that's just right for your needs, whether it's the season, the tastes, or the method of storage. Some cultivars of apple even contain more vitamins than others, which can help you with your health in an accessible and delicious way.
That's right, Ashley. Farmers can crossbreed different varieties to produce new results. And when they want to grow some more, they can do so by grafting branches of the tree to rootstocks.
From what I've read, some apples are good for long-term storage, while others are especially really good for cooking or turning into juices.
Who knew there was so much nuance to apples, huh?
Yeah, I kind of wonder if there's someone out there who's eaten every kind of apple in the world.
All right. Perhaps we can talk about it on our next episode.
Well, there's another way for apples to address food insecurity. Trisha, how familiar are you with GMOs?
GMOs, like genetically modified organisms?
Yeah, that's the one. But for our listeners who are unfamiliar, they're basically organisms like plants or animals that get their DNA altered through genetic technology. Are you familiar with any examples?
Hmm. I know corn is GMO to prevent pests, and sometimes potatoes too. Yeah, I think so.
Yep, that's true. And apples have a GMO of their own.
Oh yes, the Arctic apples. They were genetically modified by the Okanagan Specialty Fruits Inc. so that they don't brown. Arctic apples have been in stores since the mid 2010s ish.
Yeah. And I believe they were also patented by the company that made them. I can't believe patented apples are real, but here we are. But
Yeah, they are. Can't believe patent apples are also real, but here we are. Since they don't brown quickly like normal apples do, less apples need to be thrown away, whether it's with people or within the supply chain.
yeah, and I can imagine a lot of apples get thrown away in the process of making all those food and drinks, or even when it's just on the way to the supermarket.
Yeah, I know. And sometimes people who face food insecurity might not have a fridge, even a house, but with Arctic apples, they can still enjoy fresh and non-brown apple slices.
Yeah, it helps with food waste and food insecurity. But when GMOs started becoming more well known, a lot of concerns rose up about it too, including about the Arctic apples.
That is true, Ashley, but the US Food and Drug Administration had tested it for years and years before it hit the shelves. Plus, it's super likely that we've been eating GMO foods without even realizing it. Hey Ashley, how are the Arctic apples made anyway?
Oh yeah, that's a good question. So the way scientists created Arctic apples was through something called RNA interference. I won't get too specific with the details, but it's a technique that lets certain genes be silenced. Polyphenol oxidase, or PPO, is the enzyme that makes the fruits turn brown.
Oh, by using RNA interference, they made it so that the PPO is expressed 10% less often than normal. The information in the gene that says produce PPO basically gets skipped over. Isn't that cool?
It is, but doesn't it affect other things in the apple?
Well, according to the research, it doesn't, so Arctic apples are still safe to eat.
That's good.
Yeah. Okay, so with that, we've reached the end of our podcast. There are lots, there are a lot more details about apples than I expected.
Yeah, me too. Before this podcast, I didn't even know they had all of this history and things about GMOs.
But still, Malus X Domestica aren't invincible. They face diseases a lot, whether it's through viruses or bacteria, or even fungi. Some of the most widely eaten cultivars were even found to be closely related to each other, which makes them more vulnerable to disease and environmental changes.
So, what is in store for apples in the future?
Apple breeders and scientists are looking into the genetics across lots of different cultivars and apple species. They think that they'll find new traits or information to help battle against diseases.
Oh, yeah, I think I read in one article that they're even looking back to the ancestors of Malus ex domestica, like the Malus siversi.
Mm. It just goes to show that sometimes we need to look into our past in order to figure out the right path for the future.
Well, maybe in another century or a millennium, we'll have the perfect apple. Maybe it doesn't brown and can be stored forever.
Maybe, but either way, that's all for this episode of our podcast. We hope you all learned something new and thank you for listening. Adios.
Thank you. Bye.